Welcome back. In this video, what we're going to do is we're going to look at integrating things with the trig functions and the inverse trig functions. And this is the basic trig, the other basic trig function. So we already know sine and cosine. So the antiderivative of tangent is negative ln of cosine of u plus c. We can also write that negative right there is an exponent on cosine. So the reciprocal of cosine is secant. So we can write it as ln of secant of u plus c. You can see it written either way. Antiderivative of cotangent is ln of sine. Secant is ln of secant plus tangent. Cosecant is ln of cosecant minus cotangent. Some examples of those, again, use substitution. So u is x squared. Du is 2x dx. Multiply it by 1/2 out front. So it's 1/2 times the integral cotangent of u du, which is going to be 1/2 times the ln of the absolute value of the sine of u, which is x squared, plus c. Again, just memorizing these patterns for the most part on these ones. The tangent of x over 2, so this time u is x over 2. Du is 1/2 of dx. Gets people a little bit confused sometimes. Now we're going to multiply both sides by 2 instead of multiplying by 1/2. So it's 2 times the integral of the tangent of u du, which is going to, the answer on that is going to be negative 2 ln of the absolute value of the cosine of x over 2 plus c. Or the other way of writing it would be 2 ln of the secant of x over 2 plus c. Either one of those will work. Little secant one, so if u is e to the 2x, then du is 2e to the 2x. I'm going to multiply by 1/2, so it's going to be 1/2 times the integral of the secant of u du, which ultimately is going to be 1/2 times the ln of the absolute value of the secant of e to the 2x plus the tangent of e to the 2x plus c. Again, all that use substitution that we've been doing, still applies. This one gets a little bit trickier. We have cosecant of x minus 1 quantity squared. We can't just let u be cosecant of x minus 1 because then the derivative of that would be negative cosecant times cotangent, and that's not going to work. We don't have any cotangents in there anywhere. But what you can do is you can square out this binomial. So I can write it as cosecant of square root of x plus, let's see, that's a minus 2 times the cosecant of x plus 1 dx. Antiderivative of cosecant square root of x is that negative cotangent. That was from earlier on, the very first video on integration, we learned that. And then this one's going to be minus 2 times the ln of the absolute value of cosecant of x minus cotangent of x. That's the new one. And then plus x plus c. We also take a look at some inverse trig functions here. We look at the antiderivative involving inverse sine and inverse tangent. The antiderivative of 1 over a squared minus u squared du is inverse sine, and the antiderivative of 1 over a squared plus u squared is inverse tangent. And make sure you get that 1 over a. That's on tangent but not on sine. Some examples of those. The 4 is a constant out front, so this antiderivative, I don't need any u substitution. That is u squared. A squared is 1, so a is 1. That's u squared, so u is just x. So it's going to be 4 times the inverse tangent of just x plus c. There's no 1 over a out front because it's 1 over 1. This one, if u squared is e to the 4x, then u is e to the 2x. Then du is 2e to the 2x dx. So then I can pull a 2 out front, or you can pull 1/2 out front. That e to the 2x dx is my numerator, so I can write it as 1 over the square root of 1 minus u squared du, which that antiderivative then is inverse sine. So it's going to be the antiderivative, which is 1/2, my inverse sine of u, which is e to the 2x plus c. couple more examples, get a little bit trickier. In this one, I have an a value is 4, so that, a squared is 4, so a is going to be 2. And then u squared I want to be x cubed. The next couple of examples on here, I'm going to show you differences of when I'm going to use ln versus when I'm going to use inverse tangent. This one, if you look at the powers, this one is 4 powers less than this. So this has to be somehow inverse tangent. If it's exactly 1 power less, then you want to use ln. So in this case, if u squared equals x to the 6th, then u is x cubed, and du is 3x squared dx. So now I'm going to pull 1/3 out front. That x squared dx is my numerator, so it's 1/3 times the integral of 1 over, it's going to be 2 squared plus u squared du. Antiderivative, that's inverse tangent, so it's going to be 1/3 times 1 over a, which is 2, times my inverse tangent of u over a plus c. And then I would combine it a little bit, so it'd be 1/6 inverse tangent of x cubed over 2 plus c. Now, this one differs from my next one, because if you look in this one, this looks like it might be inverse tangent, but it's actually ln, because this power is exactly 1 less than this one. So if I let u be x squared plus 25, then du is 2x dx. And that x dx in the numerator is 1/2 of du. So I can write it as 1/2 times the integral of 1 over u du, which is just 1/2 ln of the absolute value of x squared plus 25 plus c. And you do have to know the difference between those. They can't use them interchangeably. It can't be like inverse tangent or ln. It's not. It's unique. So it's one or it's the other. And then finally, in this last one, we get into some problems where we have to complete the square. And this is also related to inverse tangent. If you get something like this, I can't let that be u because I don't have anything in the numerator to take care of it. What I can do is I can rewrite this one this way. Rewrite it as 1 over, and then group the x squared plus 6x plus something. We're going to complete the square there. And then outside, it's going to be plus 13. And whatever we add over here on the left in parentheses, we have to subtract right here to keep it equivalent. So then to complete the square, we take half of this b value, which is 3, and then square it. So that's 9. So then this is 9. And then what I can do is I can rewrite this equation. This is a perfectly squared binomial, so I can write it as 1 over, this is going to be x plus 3, quantity squared, and then it's b plus 4 dx. This part right here, the x plus 3, can be u, so u squared is x plus 3 squared, so u is x plus 3. And this part that's 4 is a, or a squared, so a is 2. So the antiderivative is inverse tangent. So it's going to be 1 over 2, 1 over a, times the inverse tangent of u over a, which is going to be x plus 3 over 2, plus my constant value. All right. So definitely a little bit harder in terms of the algebra and like simplifying things down and recognizing when to use what rule. Try to do the best I can to clarify more for you in class. You do have to learn all these antiderivatives, so just sitting down and memorizing, making some flashcards is going to be important for you. See you back in class.